Hi kids, welcome to lesson 4.10 through 4.12, triangle congruence proof. So we're going to be proving triangles congruent using our two-column proof method. You're starting with your warm-up from our previous lesson where we talked about the different ways to prove that triangles were congruent using the side, 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 angle, side, where the angle is made up of the two sides, or the angle, side, angle, where the side is shared with these two angles, or angle, angle, side. It would be in a row, or hypotenuse leg methods. This is with only right triangles. But right triangles can also have side, angle, side. So you have to be careful. So look over the warm-up. This is like some of your previous work. Pause the video and then come back and check your work. Okay, here you do not have enough information. Even though you know that this segment is congruent to itself, you don't know anything about the other angles or other sides. Here you do know that you have congruent angles, two sets, and then you have vertical angles here, which are congruent, but there is no angle, angle, angle triangle congruency. Think about equilateral triangles. Like, let's pretend that's equilateral, and that one's equilateral. Let's just give them notation. These are both equilateral triangles, and these angles are all 60 degrees. These are all 60 degrees, but these are not congruent triangles. Okay. We do have a right angle here. It's a vertical angle, so that makes that a right angle. But I am looking at side, angle, side here. My hypotenuse is not even in play. Same thing here. I got vertical angles, so that's a right angle. And I've got side, angle, side, which corresponds to side, angle, side. No hypotenuse in play. All right, let's get started on some two-column proofs. So we're going to work these examples together, and I want you to follow along and work with me. The more you do them, the easier they get. So I'm given O is the midpoint of MQ. Okay, so there's O, and it's the midpoint of MQ. They've already marked it as congruent and congruent. If they hadn't, I would have marked it. But I know since it's being given the midpoint, I'm going to have to use definite midpoint in my proof. So here, O is the midpoint of MQ. That was given to me. And now I know that MO is congruent to QO, and that is by definition of midpoint. Now that tells me O is the midpoint of NP. O is the midpoint of NP. That again is my given information, and if this was not notated, I would go ahead and do that. So this was given, and I know those are congruent based on the definition of midpoint. Now I've got these angles right here, MON, that's this angle, and QOP, that's this angle. They're saying they're congruent. Well, what's the reason they can make that statement? Because those are the vertical angles, and vertical angle theorem states that all vertical angles are congruent. All right, so now that I've done that, I have a side, an angle, and a side. This angle is made up of these two sides, and I have the corresponding notation over here. So I can state that I have congruent triangles by the side, angle, side, triangle congruency. And it's also a theorem. Okay. Take a moment to absorb that. You can pause the video, look at it. Let's go into another example. All right, here, let's take a look at our given information. They're telling me right away that LA is parallel to SN. Whenever they tell me that, I like to extend my parallel lines just so I can kind of see them a little better. Okay, and that means I know I've got transversals. I've got this transversal, and I've got this transversal. Okay, LA is parallel to SN. That is given to me. I've kind of digested that on the diagram. Now they're telling me that angle L is congruent to angle N. So that's this angle L is congruent to this angle N. Well, I know that they are congruent because they are on opposite sides of this transversal. Right here, they're on opposite sides, and they're inside the parallel lines. So this is alternate interior angles theorem. Then I've got LR is congruent to NR. LR is congruent to NR. This was given information. Now they're telling me the angle LRA, that's this angle here, I'm going to give it 2 because it doesn't match that one, is congruent to NRS. NRS, that's this one. Okay, why are they allowed to make that statement? Well, that's the vertical angles theorem. Again, vertical angles are congruent. So now when I look at this, I'm thinking, okay, I'm ready to make my triangle congruency statement. I have an angle, a side, and an angle. On this one triangle, the side is trapped between the two angles, and I have the same corresponding notation on the side. So I've got angle, side, angle, triangle, congruency theorem. You can pause the video to digest and come back. This one is actually the same as number 1. So let's look at the next one. Okay, here. Now I don't have my 2 columns set up, so I'm going to do that first. Let's go ahead and, I guess I could do it nice. Okay, and I'm going to put my statements on one side and my reasons on the other. So let's start with our given information, kind of mark up our diagram, and let's know where we're going before we even start. I'm given that AB is congruent to AD. Okay, so I'll make that statement and make that it's given. Let's look some more. I've got BC is congruent to CD. Okay, so I'll make that statement and that it's given. Now looking at the diagram, I'm thinking, is there anything else I can mark? Well, I know that that's congruent to each other because of that reflexive property. So I'll have to make that statement and use that reason. Now, okay, I'm looking at it and I see that I've got side, side, side. So I know I'm going to use side, 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 triangle congruency. Now I'm ready to start my proof. So I'm going to take my first little statement, that AB is congruent to AD. That was given. Then I have my second statement I want to make, goes with that notation, that BC is congruent to CD. That was also given. I added the notation here that AC is congruent to AC, and I was able to add that notation because of the reflexive property of congruency. After I did that, I noticed, I've made my proof. So my last statement is going to be what I was trying to prove. And that is triangle ABC is congruent to triangle ADC. And I already knew before I even started that I was going to be using side, 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 triangle congruency theorem. Again, you can pause and digest. Let's move on to number 5. I'm going to set up my little T-chart. Unable to recognize. Let's try that again. There we go. Okay. So let's start looking at the diagram and see where we're at. Now, I'm looking at this, I'm thinking PN bisects MNO. So PN, I've got these congruent angles right there. I know I'm going to have to use definition of bisects because they told me something bisects. So I'm probably going to have to state something that this angle is congruent to this angle because of definition of bisects. They also tell me that MN is congruent to NO. Okay, and then I'm thinking to myself, is there anything else I can mark? Yeah, I know that NP is congruent to NP by the reflexive property. And once I do that, I add that marking, I'm looking at it and I'm thinking, oh goodness, I have side, angle, side. So I know I'm going to use side, angle, side, triangle, congruency. Now I'm ready to start my proof. So I'm going to start with PN bisects angle MNO. And that is given to me. Okay, now remember I put this marking, I have to use definition of bisect somewhere, so I'm going to say angle MNP is congruent to angle ONP. Okay, so I've got those congruent angles now. Going back to my given, that MN is congruent to NO. That was given information. And then I added some notation that NP was congruent to NP. And I was able to add that because of the reflexive property of congruency. After I made that statement, I now know triangle MNP is congruent to triangle ONP, and I already knew that I was using side, angle, side, triangle congruency. I laid it out before I even started my proof. Okay, it looks like I'm going to be running a little short on time. I won't be able to finish the next one, number 6 here, before my video runs out. So I'm going to start a second video where we'll pick up with some more examples. We'll pick up with number 6 on the next video.